morning friends, and in this video we are going to discuss about the higher order differential equations. Higher order differential equation means when you differentiate once it is called the first order, when you differentiate it second time it is called as second order, and how it's all represented and how everything is achieved. Now let's see on blackboard. So this is called higher order differentiation. Suppose y is a function of x. Let y is a function of x. So when we differentiate both sides with respect to x, this becomes dy by dx, and this is f dash x. This is called the first order differentiation, means you have differentiated it once, that is called as first order differentiation. If you differentiate it again, so differentiating again second times, differentiating again both sides with the same respect, both sides with respect to x again, then this becomes d2y over dx square. This is just a notation, and this becomes f double dash x. So this is called second order differentiation. If you do it one more time, it will become d cube y upon dx cube is f triple dash x. Same way, if you keep on doing, then you can also find nth order of differentiation, that is d and y over dx, and or in the terms of this is written as f to the power nx, means f dash, so dash becomes n, means the nth order differentiation. This is called as higher order differentiation. Now in the first order, the significance that when you have y equal to fx, and then when you find this dy by dx, that is called the slope of the function. So dy by dx is fx, and that is called as slope. Now I explain the geometrical significance again, but first let me clear the screen. Okay, so significance of differentiation, as you all know, that if y is a function of x, it can be plotted on xy plane, where we write x on the x-axis and the fx on y-axis, or also you can call it y. Suppose if the graph goes like this, then you have taken 2 points, one is P, another is Q, this one is x, first point is x, and this is fx. Second point is, suppose if you increment in x by value h, so this is x plus h, and the function also becomes fx plus h. If you join them, then you find the chord. This is a chord. PQ is a chord, means a line on a curve. This is a chord. And if you find the slope of this line, that is m equals, using coordinate geometry, that is difference of ordinate over difference of abscissa. So difference of ordinate is fx plus h minus fx, and difference of abscissa is x plus h minus x. Now if you set this function to the limiting value of h0, so h is the increment. Suppose if h is from here to here, we are calling it as h. Like this is my x, and this point is x plus h. So this is the angle it is making. This can also be written as m equal to tan theta. And when h is tending to 0, means when h is shrinking, then this chord is also shrinking, and q is coming nearer to p. So when q and p coincide, then the line chord pq will become tangent, and this is what we are finding out. So y dash or f dash is actually the slope of the function. So when we finding y double dash, then what we are finding out? We are finding out the slope of slopes. Means a slope will also be a curve depending on the situation. Like suppose if I take example of y equal to x square. This everybody knows that this is a parabolic function. When we find dy by dx, then we are finding 2x, that is a straight line. When you are finding d2y by dx2, that is 2, that is again a line, but y is 2, so if you find this is 2, then that will be a line parallel to x-axis. So this is called the slope of slope. Same way, if I take my function as y equal to x cube plus 3x square plus 2, then this is a cubic function and it graphs somewhere, because this is a cubic function goes like this, so it will be some little manipulation because it's the sum of the three functions. One is cubic function, one is quality function like this, and one is a constant function like this. So sum of these three will give you something like that, or little different, but the order will be something like that. So when you find differentiation of this dy by dx, then you are getting 3x square plus 2x. This is again coming of this order. So again you find d2y by dx2, you are getting 6x plus 2, this is a straight line. And when you are finding d cube y over dx cube, you are finding 6. So what is this? Y is a function. What is significance of dy by dx? Slope of the function. What is significance of d square y over dx square? The slope of the slope. And what is the significance of d cube y over dx cube? Slope of the slope of the slope. Now what will be its significance? Its significance varies from the time to time and depending on situation. That is the restrictions, the field where you are applying the ideas of mathematics, where how that field accepts it. Like in physics we apply. So in physics, if I take y as a function of t, so this is, we get y equal to ft, right? Suppose y you call it as the displacement. If I take it as a linear displacement, like going along x-axis, so x equal to ft will be a function of t, where t is the time. So now when I find an x is displacement, displacement is a function of time. So when you find in dx by dt, then that becomes velocity. When you find d square x by dt square, the rate of change of velocity is called as acceleration. When you are finding the d cube x over dt square, the rate of change of acceleration, there is no any such physical quantity which takes the form of the rate of change of the acceleration. Means how fast the acceleration is changing. It may have significance, but right now the physicists do not find any resemblance with any physical quantities which is directly related with the rate of change of acceleration. So the mathematics can give you the idea, but the subject, means physics, may or may not accept it. This is the significance of the higher order differentiation. Now we will be taking some examples to solve these equations. So for that, let me clear the screen. Suppose I have a function y equal to tan inverse x. Then we have to find some derivatives of it, like the second order, third order. Let's see how long it goes. So first I say, if y equal to tan inverse x, so differentiating both sides with respect to x, what do you get? You get, we can write as y1 or y dash, that is d by dx of tan inverse x. Now what is y? That is 1 over 1 plus x square. Now what is y2? Means that is d by dx of 1 plus 1 upon 1 plus x square. Now how will you find the differentiation of this? there is one formula which says that you can use u by v rule, or you can use it in the form of 1 by x. What is differentiation of? I always tell you to do like this. 1 by differentiation of 1 by x is minus 1 by x square. How? Because 1 by x can be written as x to the power minus 1, and then minus 1 x to the power minus 2, that is minus 1 over x square. So if I have the differentiation of 1 by something, s stands for something, so differentiation of something is minus 1 over something square into differentiation of something with respect to x. So same thing, if I say the 1 by x square, will become minus 1 upon 1 plus x whole square into differentiation of something, that is 1 plus x square gives you 2x. So this is your y2. So y2 is minus 2x upon 1 plus x square whole square. Now again, if I have to find y3, means the third order differentiation. Now in this condition we have no other option but to go by u by v rule. So I'll say that minus as it is. What is u by v rule? Differentiation of u by v. What is differentiation of u by v? That is v into du by dx minus u into dv by dx upon v square. If you take in terms of numerator over denominator, then denominator into differentiation of numerator minus numerator into differentiation of denominator upon differentiation square. So now here same thing, I kept minus sign there, then I write denominator as it is 1 plus x square whole square. Then you have to find differentiation of 2x. I can take 2 also here, fine, it's constant. Now differentiation of x, that is 1 minus, this is numerator unchanged, into differentiation of 1 plus x square whole square. Now pay attention, differentiation of 1 plus x square, if I have to go in one line, so 1 plus x square whole square. To take this whole thing as something, so something to the power 2 means it's just kind of x square, this differentiation is 2x. So this will be 2 times this into differentiation of this. So this will become 2 times 1 plus x square into differentiation of this is differentiation of 1 is 0 and differentiation of x square is 2x. So 0 plus 2x, that is 2x, over this one will be squared again. So it is 1 plus x square whole square. On squaring further, this will become 1 plus x square to the power 4. Now if I simplify, that will be my y3. So y3 is minus 2. This is 1 plus x square whole square, and this is 1 plus x square. So I just take 1 plus x square common. So here I'll get 1. And then since I have taken 1 plus x square common, then I'm getting as 2 to the 4x square minus 4x square upon 1 plus x square whole to the power 4. So you can cancel 1 x to the power 4. So I don't have space here, so I simply make this one as 3 and remove this one from there. So this is your cubic. There is no end of this. If you see the way it's growing, like if you keep on doing, if you then you go nth term and then you this will be non-ending differentiation. This will never stop. So we can stop it here because they may not ask you to find out the differentiation. In the higher order, you can find the pattern into this, and you can find yn, and then using that you can find the patterns using the ideas of Leibniz, or there is always a pattern in mathematics. So now this is now I will take another example. Now there is a question: if y equal to tan x, show that y2 equal to 2y y1. y2 equal to 2y y1 means this one can also be written as d square y over dx square equal to 2y into dy by dx. We can directly verify. So write when I find dy by dx, then you will get tan x differentiation is sec square x. Then you find d square y by dx square. So now look at this properly. This is in the form of sec x whole to the power 2, means something to the power 2. Something to the power 2. So something to the power 2's differentiation. So differentiation of x square is 2x. So something to the power 2 is 2s into ds by dx. So differentiation of sec x whole square will be 2 sec x. This is my 2s. And the differentiation of s is sec x. So sec x differentiation again is sec x tan x. Now you can just directly put this value. Now you see this 2y. So if you multiply this one, this is 2 sec square x tan x. Now see properly. What is this? Dy by dx. So sec square x is just dy by dx. So this is 2 dy by dx. And what is tan x? Is it not y? So this is y. So this is y. And this is d square y over dx square. This is what it is. Now I'll just take another example to solve the very same ideas of the differential orders of higher order or second order. Now this is a special question which goes like this: y equal to sin inverse x whole square, show that 1 minus x square d square y by dx square minus x dy by dx minus 2 is 0. So now I differentiate. First let me find this y1. So I'll write differentiating both sides with respect to x. So y1 equal to, this is something square again. X square's differentiation is 2x. Something square differentiation is 2 into something into differentiation of that something. So 2 sine inverse x into differentiation of this something is 1 minus 1 upon under root 1 minus x square. Now here you see we don't have anything in the under root. So what does it mean? It looks like we have to square the pattern. So now cross multiply, you get y1 into under root 1 minus x square is 2 sine inverse x. Mathematics is not just randomly using the formula. You have to keep your eyes on each terms. Now you see y this, y sine inverse x whole square. This is sine inverse x. So if I square this, I'll get sine inverse x whole square, and that will become my y. So why not? By delaying this square. So this is y1 square. Root is gone from here. 1 minus x square, and this is 4 sine inverse x whole square, which later I can write it as y square. So what I have now? I have y1 square 1 minus x square is 4y, because sine inverse x whole square is just y. Now we have to find second order differentiation, and I'll be applying the rule of differentiation here, assuming y1 1 minus x square and the 4y all as the different functions of x only. So again you write here differentiating both sides with respect to x. Then you see this is first function. Again, whenever you see what is differentiation of x square, that is 2x. What is the differentiation of something square is 2 into something into differentiation of that something. So suppose I keep 1 minus x square as it is unchanged, because this is UV rule. So 1 minus x square unchanged, and then differentiation of y1 square. This will give you 2y1 into differentiation of y1. What will be differentiation of y1? This will be nothing but y2. So 2y1 y2 plus keep y1 square as it is. Now find differentiation of 1 minus x square, that is 0 minus 2x, that is simply minus 2x, and differentiation of 4 into y. So 4 is a constant I have taken outside. Differentiation of y will become just y1 or dy by dx. Now here you see that each term necessarily contains one term, 2y1. So I can take this 2y1 common. Then I'll be having 1 minus x square y2 minus x y1 is 4 y1. So now you see I cancel this 2y1 and this 4y1. So here I will be left with 2. And now if I transform this 2 on this side, So I'll get 1 minus x square y2 minus xy1 minus 2 is 0. Is this not the very thing what we have been asked to show that? So this is 1 minus x square, 1 minus x square, d square y over dx square is this one. This is x dy by dx, that is y1 minus 2 is 0. So this is how this kind of questions can be solved. Now I take another example just to solve one such form. Now I have taken one more example which says that if y is log x plus under root 1 plus x square whole square, show that 1 plus x square y2 plus xy1 is 2. Now how to start solving this? So let's start. So here I just start writing differentiating both sides with respect to x. So what I get dy by dx, I'll prefer writing as y1. So y1. This is again check properly. The box brackets called as brackets starting from here, and this is braces. So now it is just like something square. So again, what is differentiation of x square? 2x. What is differentiation of something square? 2 something. So 2 log x plus under root 1 plus x square. This is 2 log into differentiation of this something, means d by dx of x plus under root 1 plus x square. So again I continue. This is 2 log x plus under root 1 plus x square, and the differentiation of x, that is 1 plus differentiation of root x. Yesterday in the last video we discussed that differentiation of root x is 1 over 2 under root x. So differentiation of root something, d by dx of root something is 1 by 2 root something into differentiation of that something with respect to x. So this is root something, so it becomes 1 upon 2 under root something. This is 1 plus x square. Now differentiation of this something which is 1 plus x square is 0 plus 2x, that is 2x. This is closed. Now 2 and 2 cancel. If you take the LCM, then what do you find? You find 2 log x plus under root 1 plus x square. If you complete the LCM, you get under root 1 plus x square plus x over under root 1 plus x square, and this is my y1. Now see the tricky part. If you want to get rid of this 2 log, then you have to square it, because this again squared. If you square it, then this part will become y. So this is a good way of getting rid of this log term. So write y1 square is 4. This 2 square becomes 4, and this log something means from here to here, if it is squared, I am going to write just it as y. And then this x plus under root 1 plus x square, this one will give me a value of something squared. So now how to get rid of? Oh, I made one mistake here. First it is 2 log x, because the thing goes like this, so it can be rectified, don't worry. The thing we have in the order of y equal to log something whole square, then its dy by dx will be 2 log x. Then we have to find differentiation of this log x also, 1 by x, like that. But here we have the s also differentiated, so we need this 1 by x term. So I introduce 1 by x term, which I missed here because all these are in product form. So what is x? X is this part. So this is x plus under root 1 plus x square. Here also you have x plus under root 1 plus x square. Now you see that this part 2 becomes 4, this part becomes y, this and this cancel, and this is squared. So we have just 1 plus x square without any root upon 1 plus x square. Now let me clear that part of the screen so that we have this term only. So y1 square is 4y over 1 plus x square, so just cross multiply. 1 plus x square, 1 plus x square y1 square equal to 4y. This is the equation. This is like the parametric equation. Now I have to differentiate it again. So this is UV rule. So I keep 1 unchanged. So 1 plus x square unchanged into differentiation of again x square is 2x. So y1 square will be 2y1 into differentiation of y1, that is y2, plus keep y1 square unchanged and find differentiation of this one. This is 2x and this is 4y1. Take 2y1 common. So it is 1 plus x square y2 plus xy1 equals 4y1. Now 2y1, 4y1 cancel, you are left with 2. So the answer is 1 plus x square y2 plus xy1 equal to 2. This is what we are asked to prove. So thank you very much, and in the next video we'll just take another form. This is called differentiation of function to the power function. Thank you very much. Till then, just subscribe to our channel and keep practicing with us.